recording started. Let me put the chat on. Also, please, I know it's going to be some things are going to be a little bit dense. Please do ask questions if you have any. And feel free and do not be shy of any questions pops in your mind, because I'm trying to cover a lot of ground, and I'm going I'm going to go a little bit fast. So just if I miss to explain something, just please say, hey, this is not clear. Can you please just cover that part at least so we can have an idea what's going on? And I will gladly do so. All right, so file structures, how to actually write to a file. That's a very good question. Now, so far we have learned how to run before we learn how to walk, right? You learned how to save stuff into a database, but not everything needs to be saved on a database, right? Sometimes you need to save your information in a just simple file in a certain format. Now, the file format is going to be different from an application to another. Sometimes you would like to save binary data. Sometimes you would save XML data, that if you are actually dealing with a very old systems, probably. Actually, as a matter of fact, this project file, I think, is in XML. So if I actually go to the C# project, this project, and I, give me a minute. Let me start. Let me try to get, there we go. So this is actually in XML, right? And this is how your C# project is getting interpreted. Like if you add another project, if you add, for example, if you look at your solution, let's say, which is going to be hopefully somewhere here. Your solution, okay, it doesn't look like a C# project, doesn't look like XML anymore. But it's actually human readable, right? You can actually write a program to parse this, like to read each line of this and then do certain actions based on whatever you think is relevant, right? But this is, for example, is how your C# project keeps track of its files. So far it says, hey, please include me these references. So once your project gets compiled, it just simply looks at these references, right? If it has a missing reference, it will just simply tell you, hey, it doesn't work. But in terms of like outside of the IDE in general, XML was used in SOAP architecture. So I don't know what SOAP was. Oh, I forgot the acronym for SOAP. Hang on, SOAP. Simple Object Access Protocol. Yeah, that's the that's the acronym. So we close this. So long time ago, long time ago, like 20-something years ago, people were used to save data in XML and shoot it over network. Before JavaScript annotations or Json became a thing. And even before that, way before that, before XML and Json, we were saving stuff to hard drives, and then we send them over telephone lines, right? Now here comes the interesting part. I'm not gonna discuss how file system works, like how FAT or NTFS or a file system in general on a hard drive work. But you have to understand that we have several types of mediums to save our files or data, and based on the type of media, we get interesting writing methods. So, for example, saving data on a magnetic tape is going to be slightly different from saving data to a hard drive, right? The hard drive and SSDs right now are having almost identical thing, even though they have a different, like on a hardware level, you have a different kind of access. You don't on a hard disk drive, you have this magnetic platters, and then you have an arm which reads from these platters, right? And just magnetizes the platter or parts of the portions of the platter, so just simply writes it in this reverse inverse, like reverse and forward and backward, like these magnetic fields And then when the pin just goes through it, the arm just goes through it with a pin, it just simply like reads these differences in the magnetic fields, and it says, aha, these are zeros and ones. Now, obviously, they are split into tracks and sectors and stuff like that. We are not going to discuss this. But there is, based on this way of accessing data, we started actually to formulate how we can actually access, how we can formulate or how can we make a file system that exploits this, and how can we write an efficient file system that we can get data super fast, right? So you don't spend time seeking for the data until you get it. And this is one of the reasons why, for example, you get SQL dates, for example, SQL Server, like database, for example, sometimes it just, a lot of times you can see them as a single file. I think they can be split into multiple. I don't know. I really need to check out with somebody who actually does this, but I think it's just a single file. And it's for the sole reason because it actually has been done it has a certain file system to access data. I think if we have time in algorithms and data structure, we're going to cover B plus trees and B trees, which tells you how actually SQL works from the, like, it gives you an insight on how SQL works from the inside, right? Anyway, just as a brief story of what's going on regarding writing to a hard drive or writing to a storage, basically. There's also one more thing. Choosing the media is very important. So I think hard drives, they can retain data for for 30 years, 40 years. That if you, for example, store the data on a hard drive and then you keep it in your closet. So usually magnetic field dissipate after a certain time, right? They have a specific time that they will lose data. It is the same thing with SSDs. They will lose the data after a certain amount of time because the electric charge will not be staying there forever. It will simply, like, the energy will escape at one point because SSDs basically are just like, quote unquote, a bunch of capacitors, I would say, right? Or a capacitor-like architecture. So yeah. All right, so let me actually get into the topic. I'll just give you, like, I've thrown at you a couple of keywords and a couple of ideas. I hope that some of you might be interested in researching this. Here is a book I had when I was a student, actually. This is the best book I know of, and probably the only one I know that it's actually actually, I think it's the best in the field so far. I don't know any better ones. I've tried to find, but I couldn't. So this one is File Structures. I have it actually, like, I have the hardcover copy actually in my library, and I refer to it every now and then when I get stuck with certain techniques that I would like to, like, pull out. So they cover, like, a lot of data structures, and they cover how to write to a file, and they're using C++. And of course, it's translatable to C#. The second book here, I don't know. I haven't had, so this one is a different one. This one is the second edition. So the third edition is the latest, which came out somewhere in the 1997, I think. Yeah, 1997. So this is like the latest, the last time when this book came out, and I think it is usable until now because it basically covers engineering concepts and algorithms and how to write to a file with C++ code to follow it. So you can, like, get these concepts and translate them into C#, and you are good to go. All right, so now you have at least a resource to look at. Let's see how we can write to a file. Usually writing to a file is under system.io. Please understand that there's a concept called a logical file and a physical file. Now, a physical file is the file which you have in your hard drive, right? The physical thing. Your data exists physically as just an electric charge or a magnetic field, right? This is your data, physically exists. if you would like to start reading from that data, you have to create a logical file that you read it in memory, and then you start manipulating that file. Once you are done with manipulation, you write it back. Okay, so that's what it's all about. I'm gonna actually create one tiny class here. I'm just gonna make it my test. I'm gonna make it just my testing ground. It's a class library which is gonna have a student, just a student with an index and a name, and that's it. So I'm gonna call it File structures.core, for example, or something like that, whatever, or .entity. I should have called it entity. It doesn't matter. Student, and then oh, cool. Perfect. I love that. This is going to be ID. Let it be ID. I'll not rename it. And I'm going to override to string. Let's hope. Can it? Oh, it will be great if it generates this for me. It doesn't. Okay, fine. Asking too much. So I think I'm going to call it ID. Maybe like, I don't know. I will just see like maybe like so. For now, until I figure out what I want to do. This is almost like a live coding session, more or less. Yeah, maybe I can actually put like a dash. And I will have a name is going to equal to name, right? So right now, whenever I don't need to write student.name and student.id. I will just simply say, just simply write line the student, and it will just simply print that out. And I will actually have here student. Okie dokie. Now that we have that, I'm gonna actually split my project into multiple projects. We might end up with like 5 or 7 of them. Depending on the technique. Every technique of writing to a file will be just on its own separate project, so you can see it in isolation, okay? So maybe I'm gonna start with simple writing to a file. So I'm gonna create a new project, and it's gonna be a class library, and I'm gonna call this File Structures simple write. I'm going to call it that way. And I'm going to call this simple write for the class. And it's going to be just having a static function. So public static void write to a file. And then I'm going to have here string content. And that's pretty much it. I'm going to hard code the name of the file right in the function, because I honestly, right now it's a demo code. You can actually abstract that later on and make it much better by, for example, like having, let's say, file name string. Actually, not file name. Usually it's like a file path, which includes the path and the name of the file, right? So you can do all sorts of interesting things here. I'm going to show you in a minute, like all of these interesting techniques. Now we have that. You need to, yeah, I'm going to actually send a string because we usually like to write a string. We're going to write a string so we can read it, nothing more. So it's going to become human readable. So the first thing is, in order for you to write to a file, you need to open some sort of a channel, right? Like a channel that says, "Hey, I'm gonna write to a hard drive," right? This is the first thing. The second thing here is, once you are done, you have to close the file, because if you don't close it, it means that nothing will be written on the hard drive. Okay. So this is how system, even like, I think it's like on the fundamental level, this is how it actually works. You open like some sort of a logical file in the memory, and then you do your own thing. And if you don't close the file, the thing will just go away and forget it, right? Also, please keep in mind that, I mean, again, it depending on the implementation, just to be clear here. Just keep in mind that writing and reading to a hard drive is a how do you call this? It's a low-level resource. It's an operating system, like you're going to do some certain operating system calls. It's a low-level call right now. That's why you need to be careful. When you are done, you really need to say, hey, I'm done. So the operating system, on the operating system level, everything will be closed and cleaned after you, okay? So I'm going to open something which is called Stream Writer. I'm going to call this SW equal to new Stream Writer. And this happens to be in the system.io. And right now you need to provide a stream. What are you going to write? Okay, stream reader, stream writer, file streams, all of them they inherit from a class called stream. Okay, so that's a very important thing. One of the things it takes multiple things. Obviously, have multiple options there, including the encoding, which is very important. Because if you are working with multiple languages, you would like to make sure that you are reading and writing the file consistency with a certain encoding. So for example, if you are parsing a file with numbers and you find dots, you know that you need to make sure that these dots are, for example, decimal points instead of number separators. So in Bosnian language, it's about, and I think as well English, UK, local, the dot is a separator in the number. However, in the American English, they have the dot is a decimal point that represents a fraction. So you really need to be careful how you parse strings and stuff like that. So that's why you have encoding, and encoding and locales as well, like how you. Encoding as well helps you out in parsing. If you actually use ASCII and you are parsing Bosnian text, you will lose the ch, zh, ch, and on all these things, right? So yeah, keep that in mind. Now I'm going to actually name a file here. I'm going to call this my text or record.txt. Oh, even better, I'll do just data. Now here's the thing. I think it would be much easier to show you the proper way instead of like showing you the flat way. So I'm gonna have using, and I hope that you actually have seen this before. So var fs equal to new. Yeah, you see it's already know this. File stream. It will take the content and it will write it. File mode, open or create. And there's another feature. I think in C#, 8 right now you can actually put a semicolon here, and you don't need to worry about the dispose. C# will understand that it will need to dispose these resources once it reaches here, because these are low-level resources that needs to be managed by hand. So you need to make sure that you close the file and you dispose it from memory. That's why we are having this using statement. Using statement works with classes that they implement iDisposable interface. So you cannot say using var std equals to new student. It will immediately scream at you and say that the student doesn't implement. Hang on. Yeah, I need to import core. Simple right. Project solution. This. So I'm just to show you here. And right now I'm just gonna import that. And right now it should give me an error. It says it has to be implementing the iDisposable interface. So How to properly implement disposable interface. You have already an article on that on MSDN. I will share it with you. And just please remind me to do that. But this is just another story. And since I don't need this here, so I'm just going to erase it right now. And let's move forward. So we have another using. You can nest them, by the way. And I'm nesting them in that way because it's easier to handle, at least to read. Stream writer. And then right now, you have to tell the stream writer what kind of a stream it will use. So you say, hey, I'm going to open a channel, which is going to be reading or writing to a file, right? Right now it says open or create, means that open the file if it exists. If it doesn't exist, just create it, okay? And it says, okay, with that stream open, I'm going to write to that stream, right? So we're going to use a stream writer. So we're going to write in that thing, okay? And right here, you can say sw.writeLine. This is actually like exactly like console.writeLine. There's nothing fancy about it. This is it. Right now, you have written to a file. Congratulations, you are done. It's really that easy. It's not difficult at all. Just if you actually forget this, forget to close this, or forget to dispose this, the file will not be you will not be able to open the file because some programs, for example, say, hey, this file is already in use, close the program which is using it, and then you can open the file again, which ends up with you restarting Windows just that you just like destroy that reference in memory. It's like a memory leak, let's say, okay? So be sure that you close everything after you are done. And this is nested, by the way, so this is something like this, okay? But I'm just simply writing it like this because it's easier. Usually it is, if you really would like to have it that way, so it's like this, okay? But I'm not gonna write it in that format anymore because it's much easier for me like to chain them in that way. Later on, we're gonna have a stream reader and stream writer. All of them are all like stacked. And let's see how to read from a file. So public static void read from file, which is going to be string. Oh, actually, there's no need for it. It's not a void. It should be like return to me a string because I need to read the thing. And I'm going to actually use the same thing here. I'm just going to say, hey, yeah, I forgot to say that I need to, hang on. This actually needs a file name. Apologies about that. I actually forgot that I should have. So you see it has this integer pointer handle. Hang on. The safe handle, the string path. There you go. This is what I have to use. So right now I'm just going to call this. What was the name of it? This simple write.txt. And if you mention this without mentioning any slashes or anything, it will immediately go to the place beside the executable. So where you so if I hang on, let me Control K C this, Control Shift B to build, and if I go right here, the file will appear right beside the exe because I said just the name. If I start putting slashes and define a different path, then you will just simply have a different path. And I will show you in a minute how this can be done. If you would like, for example, to have a subfolder beside the exe file and so on and so forth, I can show you as well the folder operations. And here we are not going to use a stream writer, we're going to use a stream reader. So this one is a little bit different. So stream reader, using the same file stream. And I will just simply say read the file. Now, there are multiple ways of doing this. You could just simply say sr.read read to end. So it will read just the whole thing until the end. And this one will return to you a string. So you can just simply say return, right? Return. And you are just simply done. I'm going to show you a different way of doing this. Sometimes you would like to read line by line to check for certain thing. So let me see here. I will actually include in the references the simple write. Actually, it should have been simple read write, but fine, you get the idea. And here I'm just going to have simple write, and please import this dot write to a file, and I'm going to have here content will be new student. Oh yeah, we need to import the core. So there we go. Here's the core, and add it into the using. And right now we need to provide the name and an ID. So I'm going to give an ID which is going to be like whatever it is, and a name will be like come on, I need a name. Well, let me see what name do we have here. Haris, there you go. I don't know, I just simply chosen one at random, dot to string. So right now I just simply created an object and I just simply written it right there. And the simple write dot read from file. And because I know already I hard coded the file name, so I don't need to provide the file name. I'm gonna just simply say console dot write line, and then you can just write. So let's see. Oh, hang on, sorry. Control F5. And there we go. We have the ID with that and the name with that. Fine. And if you go ahead into the folder, which I think it's still opened, there you go. You have simple write, you see, .txt. And if you open it, hang on, no update right now. It is written to a file, which is normal human readable file. All right, that's actually perfect. We're going somewhere. Actually, from now on, I'm going to use notepads. It's much easier to use. Okay, now that's out of the way. Let's move actually on. So this is the simplest way to write to a file. By the way, you could actually do this. And right now, because we are going to add to the existing content, it will be actually a little bit different. So maybe I can like, just to show you that this is going to be added, so new, and let me just copy this and, ooh. Okay, and then Control F5. And right now we just simply write in a new one, completely new. So yeah, I didn't add any spaces. We didn't actually append anything or any of that. Appending will come up next. Where's my? So this is how it looks like right now. See? Okay, so now that's out of the way, and let me just compile it again, just to be sure that we get the spaces in. So you can actually like add whatever you would like to add, you know, just feel free to insert the stuff. Okay, so let's see what's coming up next. Now this is all nice and dandy. However, what we would like to do is be able to make sense of the data, right? Right now, you just simply read the line or read the whole file. Like you have written to the whole file and then you read the whole file, and there's nothing useful about it so far. You cannot actually analyze data yet, right? Now there are many ways to write to a file that you can actually understand and make sense of whatever is written. And there are two ways of looking at this problem. One way is that you write the file in One way is to write something which is called like a serializable file, like so you can actually serialize data. And serialization of data means that you take an object graph in the memory, and then you save it to the file exactly like it was in the memory. The problem is, however, when you are reading from that file, you're going to read that file as a whole. You cannot read it partially. You need to read the whole thing and load it up in the memory, right? So you cannot open the file stream and then just simply like read line by line and then pick up the line which you want and then you are off to go. But no, you really need to load the whole file so you can actually make sense of it or make sense of the data. This is what JSON, for example, is. JavaScript object notations, for example, is just a serialization method. It serializes object data. So instead of saving a student like what I have saved and which you have seen, it saves like in a JavaScript object notation like format. But when you read it, when you try to parse it back to a student object, you're gonna need actually to read the whole file completely. So if there was like 100 students in there and you needed one student's Java tier, you need to read the whole thing, right? The second way of writing this is that you can start writing your own file system. So you could say, for example, okay, I would like to have key value pair. So I can say key equals to value, and then I can read from the file. And this is actually quite famous with writing configuration files. So if you ever had games or applications that you would like to save their configurations, a lot of people just simply save them in clear text with a key equal value pair. However, you need to make sure that you are consistent, because if you change the format, your program will not work. It will just simply crash because you are expecting certain data to be in certain places. So let me show you how this actually works. I'm going to actually create another project. It's a class library, and I'm going to call this key equals value, and I will call it file structures dot key equal values. Okay. Maybe equal value just to be. I know that this is not English correct, but usually programmers have this broken English in writing the names. So I'm just going to keep it that way, honoring the engineering defect. So I'm going to call this key equal value. And I'm going to have here using system.io, input output, we need it. And I'm going to have a public static void write to a file normally. Actually, we could have just made an interface and that interface has the same. You know what? Actually, I'm going to add one right while we are at it. The cool thing is I can actually for each loop on all the objects and just simply like print the thing. But yeah, it will add to the complication. You guys might be confused. How about we can delete? But just remember that you could have you have, for example, like interface disk ops, for example. Oops, ops. And then you can have, for example, void write to a file with string path and string content, and then you could have a string read from a file, and then you have a string path, for example, right? And then if you make all classes implement that interface, right now you can do interesting stuff with polymorphism, right? But we will keep this very simple for now. I just would like that you understand how reading and writing to a file can work. All right, so key equal value, right? So what we need to do is it's literally what it means. You just simply write key value stuff. So let's say you would like to write. So let me put here content string content. Actually, right now I need something more specific. I need a student, actually. Yeah, unfortunately, I'm going to have to include this guy for now because I'm not going to write interesting interfaces or abstractions for this. I just would like to show you how things work. So unfortunately, I will do this. By the way, in production, this shouldn't happen. Your system to write, your writing system shouldn't know any detail about your objects, just to be clear here. But bear with me. Student, right? And this is going to be. And right now we're going to do the same thing using fs equal to var fs equal to new file stream, and I'm going to hard code the text file. I'm going to call this key equal value.txt. Oh, by the way, the extension here doesn't matter. You could just name this whatever you want. Nobody cares. Even the system doesn't care because you could open this in Notepad and it will be readable at the end. So we said file stream, and then I say file access dot not file access, but I wanted to have actually like create, open or create. There you go. So I just simply keep overriding the file. If it is there, just simply like wipe it out and overwrite it again. Please be careful. I'm not covering. I don't know if we will have time to cover the types or the file modes like open or create or for example override the whole thing. Please research this because it means a lot. You don't want to constantly override the files. Okay, so that's very important. All right, so here using another var sw equal to new stream writer with an fs, which is good. And right now I'm just going to I'm going to actually write it in a different way. So I'm going to write actually index. How did I name it actually? ID, thank you. So I'm going to have here ID. Then equals. Actually, I could use this. Student.id sw.writeLine name equals to, and then we have student.name, right? And that's it. You write your file in a key value pair, okay? If I have a public static void read from file, read from a file, it's not void, it has to be a string, sorry. Right now we're going to do exactly the same thing. However, we're going to read the whole file, right? Obviously, we cannot write anymore because a stream reader is just a simple reader, so can actually read to the end. Right now, I'm going to read the whole file. But let us actually add a little bit more twist into it in a second. Just I need to go here. And this is going to be like simple write demo. And then just simply like have this like so. I think there was like console.color, I think, or something like that. Yeah, foreground color. Foreground color red, fine by me. And right here, I'm just gonna have another one, which is, let's say, in blue, whatever. Yeah, fine by me as well. And this is gonna be key equal value demo. Ooh. Key mo. And then right now, what I'm going to do is import the last one which I've added, right? So we need to reference the key equal value pair. So I can write key equal value, and I need to import this dot write to a file, and then I can actually like have yeah, I cannot write multiple series because the way how I'm actually writing to a file, but let's say, oh, actually I could just simply copy this, paste it right here. And it's not to string anymore, it's just a student because I'm passing a student object. And then key equal value dot read from a file. And I'm gonna read the whole file for now, just for you to see. And I'm just gonna have console.writeLine this, and it will just read the complete file and write it out for me. Okay, and I'm just gonna actually copy this as well and paste it here. And instead of having any names in here, I'll just simply continue with dashes. Now consoles are like a state machine. If you don't actually flip the colors, they will in fact keep it that way until the end. So be careful about that. And let's see. So Control F5. And right now we have got this in the file. So we have, this is like the simple read write demo, and then we have the simple key equal value demo, right? So this actually works pretty fine. Now this is all nice and dandy until we need to have a proof, and the proof is here. So where is my program? And there we go. We have this key equal value, and as you can see here, it just simply writes it down. Perfect. Now it's all nice and dandy until you say, okay, Mohammed, but this is all like, yeah, fine, but where is my class? Actually, like I'm getting a string. I would like to convert this to a student, right? I'm just gonna call this key equal value. You won't like to have a student, which makes sense. So I will actually rename this read from file. No, I will not rename anything. It's already obvious, right? Let's see. Can I actually? I cannot remember honestly. I think I need to have multiple. I don't know if I can overload. I cannot remember honestly right now. Read from a file. Yeah, I think I cannot have an overload based on return type, right? You need to have, yeah, you need to have a different parameters. This is how you overload the thing. I'm just gonna say std for now. Now here's the interesting part. Right now my stream reader is not gonna be read till the end because I don't want to read the whole block. Right now I really need to read line by line. And I read line by line, I get the ID from the student, right? And then get the name of the student and then construct an object and return that object back. In fact, if you had multiple students, you had to do this, right? So you're going to be a little bit in trouble, right? So you have like a list of students in the file. You really need to you really need to return those students. So how to do that? First of all, you need to. By the way, there are multiple ways of writing this. I'm just showing you. Actually, in production, I have written something similar because I had to modify a file in the middle, and I will show you how to modify files in the middle, like insert the cursor somewhere in the middle and just simply like, modify the stuff. But we're gonna talk about this later. sr.peak. Now peak is returning the next available character. If it doesn't exist, it will not just simply consume it. And here's the interesting part. It's a method, so if it doesn't equal to -1, so -1 it will return to you if in case you reach the end of the file. Okay, so that's the important part. So while we are able to read from the file, sr, so you can say var line equal to sr.read line, and right now you are literally reading line by line. Okay. Now here's the interesting part. SR dot actually line dot split. You can actually split a line, and it will return to you an array of string. And if you split on equal, you should be able to get two things. You should be able like to get the ID and the actual ID. So you're gonna get. So if I run a split on this on equal, it will return to me an array of ID and the number, and then it will return to me name and Haris, right? Or the name, right? The actual name. The interesting part here, you can actually check if this guy is what it is, and then based on that, you actually do certain action, right? But we'll get into that in a second. So here var result of the split. So we have split the line. You can, of course, guard this if it's actually larger than 0, but I will not guard it. We already know that it's already there. Again, this is a demo code, not a production code. The concept, yes, you're going to do this in production. Yes, you can do this in production, but you have to guard, like check if the file exists, if the actual result happened, can we split the stuff, and so on and so forth. These guards and checks, I will leave this for you to do. I think you have file.exists, and it returns to you a Boolean. So there you go, you have that method for you. So you can do this. Okay, if file exists, and then you carry on. I'm just showing to you to know, just for you to know that this thing already there for you. Just use it. All right, so we have the result. Yeah, so right now we have this is already an array of string, and I know for sure because of the file format, I know for sure that the second element is going to be what I need, the data, right? And I know for sure that the order is ID than the name, right? You could do the guard to be careful that somebody doesn't mess up with the file system, but when you're actually having a file system, you already agreed upon a certain file format, you stick with that file format, right? So right now I'm just going to say var std equals to new student. Actually, I could actually create, since I'm returning a list of students, var lst equal to new list of students, and then lst.add new student. And I'm just going to say result. So we have an ID and a name, and the ID was an integer. So I'm just going to say int.parse. Here I'm just going to have result. Oh, the result, like the first line. Actually, I could. So hang on. In one go, I need to, yeah, actually, this is one more important thing. In one go, I need to read 2 lines because I know a student record is 2 lines, by the way. So this is going to be the index number line, and then there's the result. And then I'm going to have another line. It's going to be student student name line, and this has to be a capital L, and this has to be capital L, right? And this is going to be var result. I could actually use the object if I wanted to, but so I will not confuse you. Result for index. Again, this is learning tool. Result index. Result name. Sorry. So here I'm going to have result index of 1 because I'm choosing the second element of the array because this is going to be element 0 and this is going to be element 1. And for the second line, I'm going to have, not this, this. I'm going to have result name of 1. right? And that's it. And oh, okay, hang on. I think I know the issue. Yeah, I need to, I don't have a constructor for the student, so I need to do this. So I'm just gonna have ID equals to this, and then name equals to that. And since copying and pasting is the root of all evil, I missed to say that you are splitting the student line, not the number line. Okay, so right now in one go, like in the first loop, I will read 2 lines, and then the next loop I will read another 2 lines, and so on and so forth, right? And once I'm done, I'm just gonna simply say return the LST, and we are good to go. Okay, so this is key equal value. Nothing that fancy, I think. Let us see. Let's do a demo, and then we have a break. Okay. Actually, like going relatively, I'm actually going very slow, and I need to go a little bit faster so I can have time for the rest of the thing. Red, let it be red or white. And right now I'm just gonna, yeah, I have key equal value, and I am going to not write anymore. Actually, I could comment. Okay, so just to be sure, I don't want to, or actually I want to, let it be so, like the line is already there, it's gonna be there. So foreground white equal value demo, demo with student object. I'm gonna share the source code after the class, and we don't need to write to a file anymore. However, I would like to read from a file std. Right now, of course, I cannot write this, but I'm gonna actually hit an F9 right here. F9, sorry. And F5, let's see what will happen. All right, so this is it. And the return is, yay, null, why null? What did I forget? We created a student, a list. Is it because I actually opened the file? Hang on. Target is null, that's weird. Hang on. Let me actually put a F9 right here, F5. Oh yeah, right. And then F5. Oh, it didn't execute yet. Yeah, sorry, I made a mistake. Okay. But here it is. You see? I should have actually like do apologies, I just missed the point. Sorry about that. F5 again. And yeah, continue. And right now this guy, oh, for heaven's sake, hang on. Let me actually get this into a list first. So let me just do it that way. Var results, which is going to be just a simple list of, should it be of a student? Now it works, okay. And then I'm just gonna results dot, well, actually, no need to, I'm just gonna play like, not for each or anything. I'll just simply hit F5 right now. And result should have a count, which have a student and a name. So here you go, ID and a name. Okay, so I've been successfully being able to parse from a student text file into a student object, right? Now here's here what we could do in order to make this a little bit more interesting. I could actually add more, right? So let me save this. Now, obviously, it's all repeated. I have already a demo code that will help you. that I have some generated yesterday just for you guys, for some other technique, but let me just simply write this down. So if you look at this, so there you go. We have like 17 students. All of them are being recorded, like their indices and their names. Okay, and actually, if you notice, there you go. Here's the read. Key equal value demo read. So it's me like read from the file. Okay. If you would like to, we can have a. Let me see. I think I could say result dot thing dot join. I think there was a way that I can actually. Oh, perfect. There you go. String to join this. So I actually could say console.writeLine. That string to join will actually like for every element, and it will just simply like write in a different line, and everything will go on its own course. So let me hit Control F5, and as you can see here, it just simply writes it for me. Okay. So it translated this override to string. Remember this dash from override to string? It's right here. Okay. How about this? How about I actually make it a comma, so we'll not have a problem later in the print, like when we print it out, right? So again, right now, there you go. All right. Okay, so 14:20. I will actually give you a small break before I carry on. Right now, I covered with you how to simple read and write to a file. And I've as well shown you how to, like, if you have a record that spans over multiple lines like this, if you have 3 lines, 4 lines, 10 lines, right? You can actually start parsing data one by one and just reconstruct the object which you need, okay? So right now you know how to parse data or to parse records if they span on multiple lines like this, right? Do you have any questions so far?
No, everything is fine.
Okay. I will give you a small break, 10 minutes, so until 14:30, and then we'll get back.
Okay.
Okay.
All right. Let us continue. So far, we have covered equal value, simple read and write. And right now, we can go to, yeah, why not? Let's actually discuss delimiters and file delimiters demo. Delimiters is what we say like for how delimited file formats are just, you have simple records that are being separated by a specific character, right? Either it is with a comma, dashes, special character of some sort, whatever, right? So it's really like up to the file format. For example, CSV files are called comma separated values, right? And it is literally, you can read them in like, they are comma separated, right? And this is one of the things which you might be interested to see, because you could, in fact, read this in Excel. You can actually read and write Excel files. However, I think we don't have time to cover this, to be honest. So probably some other time, I think, if we have time for it somewhere at the end of the semester, then I will show you how to write and read and write to Excel files, or create Excel files rather. But for the time being, I can actually show you something a little bit like more interesting here. So let me actually create another project. I'll just simply add a new project, class library. And I'm going to call this File Structures .csv. And I'm going to call this CSV operations, I mean. And the obvious using system.io. Dealing with input outputs. Public static void write to a file, and then we have the content of tx string. And the and right now the obvious will be like creating a file stream, and well, actually, you know what? Let me show you another way of doing this. Instead of like just simply like creating a file stream, you can in fact create a stream writer and just write to a file directly. But again, it will use again like some sort of file stream. But hey, let me show you this as well, so you can have this in your arsenal. New stream writer, and I'm just gonna say file.append text, append. Yeah, there you go, append text. And I'm gonna actually append like without the content right now, maybe. Well, actually, I'm gonna generate some stuff because it's gonna be difficult with the students bit. So I'm just gonna generate for you something here. Let's say it's gonna be like delimited file.csv, let's say so. And in fact, I will show you without the using even, just for you to see how things look like. So you don't, then I would say Shablonski, as they say, right? So you guys just at least see like what are other variations that you could use. sw.close. This is how you actually clean after yourself. Okay, you just simply close the stream once you are done. I could just simply say for this, and then I will just have 500 numbers generated. I will just simply say, please write I. Let it be like this, or actually, let it be like this. So I plus, and then I'm just gonna add comma and that's it. Okay? Actually, let it be so, and let it be so. And I'm going to go ahead here, add a file structure CSV. I'll go and say, I can actually copy this. In fact, I need to comment this because this will actually print me out too many things, which I don't want to right now. So I'm commenting this just not to have too many things on the screen. And I'm going to have, yeah, sure, white, why not? Because, or in case we activate everything, let it be yellow. And we're going to have, this doesn't return anything. And then we have writing to a CSV file, right? And I don't need this as well. And then I'm going to have here using file structures.csv. I'm going to come over here, CSV ops dot write to a file. Okay, and I'm going to go run run this, which will not show anything so far, because just simply saying writing to a CSV file. But if I actually go ahead and open this, because it's beside the exe at the end. There you go, here it is. And if I actually run this, I'll open this in Excel. Here is your file, actually. You see? So right now we have like, what, 500 values? So from 0 to 500 is actually written like in a CSV file. In case you are interested, you can actually see this in here. So I can actually show it to you like this. And I'm just simply writing a new line and just separating it with a comma. And Excel immediately detected that, and it just simply organized it. So how can we push this further, actually? We could do something like this. I could go ahead and... Actually, I need to rename this to CSV ops. Could we use the refactoring tool instead of just renaming it right away? Static void multi-column. So you can have like multi-column CSV. Right, multi-column CSV, okay? And I'm going to use the same technique right here, but I'm going to use with the using. So using stream SW equal to, SW var SW equal to new stream writer. And this time it's going to be dot, make it even wilder. Append text. So you guys have this flavor as well. And I'm going to add append text means append means add. So you add to an existing text file. Okay. Delimited file with columns, let's say, .csv, obviously. Right. And I'm going to actually like copy this, and I will just go a little bit wilder. Maybe we can have like 4,000 records. And I'm just going to append I and then append to it more things like I times 100, let's say. And then I'm going to append to that another comma. And then I'm just going to have I minus 10. Right? So we're going to have one column where the I is. So from 0 to 4,000, or from 0 to what was the number? 3,999. And then the second column will have I, whatever that I was times 100. And then the third column will be whatever that I was minus 10. Okay, so that's pretty much it. And since we are using this statement, this will be closed once we reach here. This resource will be disposed of from the memory, the file will be closed, and everybody's happy. So let's actually give this a try. So I'm just gonna copy this text and console dot. Actually, I could do both right here. CSV ops dot. Because I'm not writing specifically anything, I'm just simply generating data. I'm not writing students, right? It's just simply generating data. And then I'm going to hit Control F5. And obviously, nothing will be on the screen. But if we go here, right now we got a file, which is 68 kilobytes right now. It's actually starting to get a little bit larger. And there you go. You have 3 columns. You have 1 column in... if you save this, okay, this is regarding how we save files. So 1 column is your I, the second column is your times what was it, times 100, and the third column is minus 10, right? So right now you know how to write to a CSV file and produce columns similar to what you could see in Excel. Now please understand that actually, we could have fun with this as well. Let me actually give this one a try. So I'm just gonna have I just deleted the file so I can write it again, and I can just simply say sw.writeLine, and I can add column names. Actually, I could say, for example, like I, right, comma I times 100, comma I minus 10. Let's see how this will look like. Hopefully I didn't mess up anything. I'll just simply like add spaces to make it a little bit nice and neat. And right now it will add to it this at the end. So right now I have headers of some sort. Of course, there is no styling. This is, again, this is a CSV file. Excel has a different way of writing. So I just simply run the program, and right now I got this generated, and absolutely we got this. So I times 100, I minus 10. Okay, so right now you can run this and you get such a thing. Now for those who are actually interested in writing to Excel file, which honestly I'm not going to cover today because it's going to be too much. There are 2 ways to write an Excel file in C#. One way is to use something which is called the interoperability services, which requires that the target computer to have Excel installed with a license Excel, okay? In case that the program that you are running doesn't have Excel, like, sorry, the operating system or the computer where your software is running doesn't have Excel, there is actually a paid software, a paid plugin or paid library, if you will. Let me just find the name. I think you can find it through NuGet packages. It is free for non-commercial purposes, and you have to write, actually, you write in there non-commercial, by the way. There's like, there you go, manage NuGet packages. And then here, I think, I'll just simply write Excel there because I cannot honestly remember anymore the name of it. You see, here you go. This is Microsoft Interoperability Services. I just cannot remember. There you go, EP+. This is Core. I think this is related to .NET Core, probably. Yeah, it's legacy. Okay, but it's actually EP+. This is the one. So let me just find it for you. And there you go. This is EP+. Spreadsheets for .NET. You can actually write software that does that. And if you look at the pricing, obviously have like, you know, it costs like for commercial use, I don't know how many licenses you have per year, blah, blah, blah. But then you have the non-commercial license for personal research and experiment and personal study hobby projects without any anticipated commercial applications, non-commercial organizations, and so on and so forth. Right there, you can actually use this library. So again, please respect people's wishes. It's actually using the good faith kind of model, they say. I forgot the name of it. They are relying on you being honest when you are using their library. So yeah. Now this out of the way, so I'm just simply telling you regarding this, and actually with that library you can actually format the style of the text. You can bold it, you can make it bigger, you can change the colors. You can literally generate a neat, nice Excel file that people can actually that looks nice, right? A CSV file is some sort of a very well-known format to export a data sheet of numbers and values. Which is actually good in case you would like to deal with some huge data and you don't want to deal with Excel shenanigans. So, and actually Excel is capable of exporting to a CSV file, by the way. So you have in Excel, you can actually save as the Excel sheet as a CSV file. All right, so comma delimited files, right now you know how it works, you know how to deal with it. Obviously you can, when you read it, you just split the comma. So whenever you read the line, so if you actually look at this file, if you'd like to make sense of it, it's going to be exactly the same like the student one. You will first say, if you are parsing numbers right now, so public, actually, let me do this. So I'm not going to write the code completely. I'm just going to write the pseudocode for it. So read, and this is going to be stream reader, and obviously this is going to be SR, and this is going to be right line is going to be SR dot read line, right? You're just going to read one line, so you move the cursor, right? You are literally having a cursor like this one, which is the blinking thingy here. You have one like that when you are actually reading the line, and when you say read line, it will read this, will consume it, and will go to the next one. The moment you say read line, it will read this, and it will go to the next one, and so on and so forth. And I say read line at the beginning before I just simply insert that in the for loop, so I can actually skip parsing this, because this is just the header. Right now, this is the data, okay? So right now it's going to be while, again, it's going to be while sr dot peak doesn't equal to -1 or larger than 0, whatever it was back then. Then you just simply say sr, hey, there you go, string. Oh, come on, give me the recommendation. It was awesome. Oh, yeah, again. There we go. So right now you read the lines and you are good to go. Obviously, it's not file append text. It's actually read all lines, or what? Read all text? What? Oh yeah, right. It's actually going to return. Yeah, right. Sorry about that. It's not going to be a stream reader anymore. So I can just simply say stream reader, new stream reader. There we go. Because this will actually open a stream, this will return a stream writer. This one doesn't, so I needed to change this to a stream reader. And you are good to go. Right now you have the line, and you can split it. You can just simply say line.split, and then you split on not the ASCII or Unicode character, you split on a comma, and then you will get an array of three objects, right? Or array of a single line. Every line will be like 3 pieces, right, per line, 3-element array. Okay, I'm just gonna leave this here. So var splitted line, so you guys can actually play with this at home. That you could, in fact, if you want to, you could do this. You just simply right now you're gonna get an array of lines that has been split. So you don't need to write this in multiple steps. Anyway, this is all about the delimiters. And CSV is the most interesting one because you just simply can open it in Excel and you see it formatted instead of just looking at a pure text file, right? Now let's see. We have a couple of more actually. We have cursor operations, which I wanted to show you, and we have serialization, which you're gonna use in production for sure when you actually like do full stack development. And I actually use it in game dev a lot. Actually, like in game dev, we are totally living on that concept, serialization. So yeah, let's actually start with, let's get started with cursor operations, and then we move on. Actually, there's one more, the indexing, file indexing bit, which is simulating a little bit of database stuff. But actually, this would be this would be better to show the cursor operations and then the index, so you will see why we are doing the indexing bit. So let me actually create this. I'm going to have a new project. I'm going to call this file structures cursor operations. I'm going to hit create. I'm going to call this cursor. Again, please understand that this code is mostly like demo code, and that's why namings are horrendous. But hopefully you get the idea. All right, so we need to create a file. So let me actually like have a file here, an existing one. So I'm going to call this test cursor, and I'm gonna drag it right here. And test cursor will be, say for example, hello world, and then intro to file structures at fit. Just having 3 liners right there, just a simple text file with 3 lines of code. And right there, I'm gonna actually like having a public static read. Actually, let me show you a couple of things as well. I forgot to show you the directory operations, how to create directories and stuff. Yeah. All right, so let me show you first a couple of things. How to write to a specific location and then write to a specific line, okay? So public static void write to a specific line. Right now you can actually provide your string data and then int line number, right? And I've actually done exactly this thing when I was generating templates for code. So I'm actually like, when I code in Unity, I generate namespaces and stuff like that. And when I generate the C# code, I need to insert data at a certain location or code at a certain location in the file. So I actually almost done something similar like this. So I'm gonna have okay. So yeah, one thing to mention here: if you would like to modify a file, unfortunately you have to load it in the memory modify it, and then write it back. If the file is big, you're going to actually read that file really in the memory, and then you modify it, and then you write that huge thing back again. There is, to my knowledge, or at least according to what I've researched, you cannot actually modify a file in place, like somewhere in between, and just simply close it. You cannot do that. You really need to read the file into the memory and then just do your operations and then write it back. And this is why you're going to see an interesting chain of stream reader and stream writer on a file stream. So I'm just going to have, let me show you this. So using var fs equal to new file stream. Right? And I'm going to import system.io. And I forgot the name of the file, to be honest. Test cursor. Okay. So I'm just going to right here, test cursor .txt. Very important. File mode. You can actually say open, because I'm actually going to be simply opening the file. I'm going to chain alongside with it a stream reader, which you will use the fs. And I'm going to chain along with it a stream writer this time, and which will take fs as well. I'm making a file stream, I'm opening a channel, and I'm going to do a reading and writing. Okay, and what I'm going to do is I'm just going to read my file. So I'm going to have a var my file, which the file which I'm reading equals to new list of strings, because what I'm about to do is reading, because I said I'm going to write to a specific line, right? So I would like to write at line 1, for example, like between those 3 lines. So the second line, let's say. So I would like to write my stuff right. Let's see, text cursor. I would like to write it right here. Okay, so that's at least the plan. So I'm gonna actually like, what you can do is that you could actually like read all the stuff until the end, or you can actually start reading line by line and adding it to the array here. So sr.peak doesn't equal to -1. So if you don't reach the, while you are still haven't reached the end of the file, my file.add sr.readline, right? So whatever you see in that, just simply add it to that list. So it will read, simply start to read this line by line. So it will get hello world first, then enter to file structures, then add field. Okay. And then what I can do, I just simply say, okay, because this is a list basically, what I could say is say my file dot insert, right? And then insert whatever data I would like to have. So insert at index, so line number in my case, and data, which you're going to insert, right? It's exactly the same thing when you insert an integer in a list of integers a certain position in the array, and that's pretty much it. There's nothing fancy about this. And then after I'm done, I'm just going to actually say fs.set position. Actually, I don't need this, but you see this is actually controlling where your cursor is going to be. Actually, I need this to be, in fact, because once you are actually reading, so you are actually working with the file reading until the end, you actually ended with the cursor right here. So once you ended up with the while loop and you are here, your file stream, the cursor, the blinking thing which you see right now is actually standing right here. If I don't set this position to 0 back again, it will take the full content, because I read the whole array, right? I read the whole file. It will repeat it in below. I will actually show you the effect of it in a second, but let me show you the right way, and then show you later on what's going to happen once you do this in a wrong way. So I'm going to have write. So please, with a stream writer, please write into the file, my file dot join, sorry, string dot join. It's actually you have a method join, and method join actually can take I think an array at a certain point, an array of strings with a separator. So my separator is going to be a new line because I read actually line by line. So I'm going to have here /n. This is my separator. Actually, it's a string, sorry. And please take my array. So it's going to be like my file. And it is done. Hopefully. Oh, there we go. All right. So right now I'm going to write exactly the specific line. So if I actually run this, once I include first this cursor operations, and I will go over here and say console dot. Yeah, let's actually pick up another color, maybe blue. I don't know. Dark blue. Hang on. Is there something crazier? Cyan. Perfect. Oh, the right line. Then we have. Actually, I could have copied this. Writing to a specific location, specific line, let's say. And then here I'm gonna call this what it was here, cursor. We need R. Okay, I got. What did I? Yeah, I didn't spell it right. Write to a specific line. Okay, and obviously I need to insert some data, so I'm just gonna say injected or inserted line. And I need to pass in the line number, which is, let's see, is going to be 1. So you have a 0 based, so we should be on the second line if my calculations are correct. So let me do this and Control F5. And nothing exploded so far, which is perfect. So right now, if I actually go ahead here, text cursor, it's 1 kilobyte right now. Oh boy, I made a mistake apparently. Yeah, okay, hang on. I think, should it be, oh boy, sorry about that. So let me hit, oh yeah, okay, let me actually like delete, let me just simply delete this file. Or, no, I shouldn't delete it, hang on. Undo. And I would like to take this guy. What the heck? Okay, let me just, weird, I think. Oh, now it's visible, okay. It actually cached it. So you see, it's actually there. Yeah, because I actually needed to invert my my slash there, nothing more. So let me actually like X this, close this, minimize this, and Control F5. And of course, nothing is happening here because no output yet. But if we actually put this here, you see, hello world, inserted line, and then enter the file structures and so on and so forth, okay? So this is how to like insert a certain line. You really need to read the whole file, interpret it, find where you would like to insert your stuff. Once inserted, you need to insert the full file back again. Okay, so that's how things work. You can actually combine things with writing to a file, like how to write to a specific line with writing to a specific character, or like place, exact place, specific location. So you don't need to like read the full file in the memory, but you can read part of it, let's say. But again, we are simplifying things here. I'm just introducing you to that world, and then you go ahead and play with this. I advise you really to learn this. It's very, very important. Write to a specific location. So let's say you would like to write to a specific location in the file, specific character. Like I would like to write, let's say, somewhere. Oh, where I lost the thing. Did I? Notepads. Let's say I would like to write somewhere like here. Let's say in here. I would like to insert my stuff, inject it in there, right? So how can we do that? First of all, you need to know where is it. That's the first thing you need to know. And then you would like to, and then you can do whatever you wanted to do, right? So I'm gonna copy exactly the same thing because I'm doing the same operation again. And obviously right now, if this runs again, I will have another line inserted. So, but who cares? It's fun. Right. And now here's another way of reading the whole thing. You could actually say var my file equals to sr.read to end. And what read to end, it will actually grab the whole string, right? So the whole file is going to be just a single string object. So I'm just going to do that for now, okay? Just as another way of resolving this. So var result equals to my file. The cool thing about this is that in strings, you can actually insert at a certain index and a certain value you can have here. So you can say, okay, take the location and take the data, just push it in there. Again, fs.position equals to 0 because I would like to begin from the start of the file, and then just simply sw.write and just simply write all the changes with the current data. This is it. Now you need to count. Now actually, I need to count this because I really don't know I really don't know how many characters is there. So let's see. So if I actually like have this, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think this is 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, and then I would like to insert everything else, right? So I can just simply say, so 20, right? Just I need to remember that number. So right now I can just simply copy this. Magenta. And here I'm gonna just simply say injected. And this is gonna be 20, and I need to, oops, 20 I said. And I need to add space because I am actually counting after the previous space, because if this is 20, it will insert right after 20, and then we need to have injected in the line. Hopefully I'm not mistaken in that regard. So let us actually, let me comment this so this will not happen again. And then Control F5. Ooh. Okay, so this is actually, it killed it right there. What did I? Bounds of the list. Really? What did I? Okay, how about I actually add a small number? Let's see, 5. I don't know if this is... Yeah, it's actually dying on me. Hang on a sec. Is the file already still there? Yep, it's actually still there. Did I make a mistake in the name of the file? No. Did I? Hang on, let me read this again. Well, yeah. It says index must be within the bounds of the list. Within the bounds of the list. What list? Hang on. Actually, I should have read which line number this is producing, eh? There we go. Inserted a specific line. What did I... Oh, right to a specific location. Okay, fine. My bad. So Control F5 right now, it works. Wrong function call. Yeah, this is fun. And right now, we could go here. And, oh, actually, I made a mistake. It's actually 20 is the actual space, so I should have added in a different way. But hey, it's actually there. You see, it's injected. So, like, let me actually, like, Control S that. And let me X this. And since I already have 20, actually, you could just simply write 21 then. There we go. And Control F5. I don't need to modify the string. And if I read this, you see, it's injected right here. So right now you know how to read from a file, write to a file, write to a specific line, write to a specific location into a file, right? So you can inject stuff in there. And I think in production you will see a lot of these operations, but of course you're going to have to write more optimized code, I think, rather than this. Probably it's, yeah, I mean, it depends where it runs. If it runs on a local machine, probably fine, but if it's running on a server, it's going to be a little bit sensitive. You need to be careful of how much memory you consume when you are reading and writing to files and stuff. But again, it's a demo code. You can totally go by it until people just simply complain, I think. I don't know. Anyway, now, as you already have seen, in order for me to read or write to a file, I really need to read the whole thing in memory, unfortunately, right? And if you want to escape this problem, you need to start thinking about, like, how can we mitigate this issue? Like, I don't want to read 1 gigabyte file in the memory, right? If you look at SQL Server, they don't read if the database is 100 terabytes or 200 terabytes, whatever, you don't actually read 200 terabytes in the RAM, so you can do your select statement, right? So what we do is, people usually do, like how database engines are being programmed, people use the B trees and B plus trees data structures. Long time ago, before that, people were using something which is called indexers. And what you're going to see is something similar, like, actually not similar, but like slightly looking like what SQL does. So I'm going to show you that. I have already files prepared for this, so I don't need to generate it in front of you. Let me just find, let me find this, where is my executable though? index demo. So, oh, actually, I forgot one more thing. Let me show you a couple of operations which I wanted to talk about, which is directory operations. So let me just say here, directory operations. They don't deserve a class on their own, but just you would like to manipulate directories. What if you wanted to create a directory, right? So that's a good question, right? First of all, we need to import system.io, which is already there, perfect. And I'm just gonna say directory dot, and actually, of course, you have directory infos, and you can inspect tons of stuff. But you can say create, dot create directory, right? And it's simple. You can just simply say my directory, right? So that's one way of doing this, right? If you would like to have multiple subdirectories, like you have a directory and then another one, you can just simply say some other child directory. And it should actually create two directories, the parent and the child, and both of them will be beside the executable of your program. Okay, so if I had hang on, so if I hit Control F5 here, and obviously nothing is being shown because this doesn't have any returns, but right now I have my directory and some other child directory, right? The cool thing here, however, is if I actually go over here and just simply I'll paste this, and this is my index demo, which has data organized in separate files. And for example, you would like to list the directory. What you could do is you could just simply say console.writeLine, and then string.join on a \n, I think. Yeah, it's a backslash, correct. And then directory. No, I'm not going to do that. I'm just going to say directory dot enumerate files, right? And what it will do, it will just simply say enumerate over the files which you have in your directory, right? But you need to know which directory you are in. Like I would like to enumerate all the files which I have in my directory. So I'm just going to say directory dot get current directory, and that's it, I think. And I will just simply say console.color, background color equals to color dot what was the first one? Magenta. Then you're gonna be red. Fine. I want it just to stand out as much as I can. Yeah. So if I hit Control F5 right now, I see all the files within my directory, within my current directory, right? This is how my directory looks like right now. I don't know why I have so many of those, but who cares? Okay. What you could do as well, you could actually like enumerate files. And then you could have like something along the lines of this will be my root directory. So if I list this, this is my C drive right now. Okay, so you can actually hunt any directory in the system if you want to. It's you can hunt specific locations in your application. And right now this is enumerate files. What if I actually wanted to have just my directories, nothing more? I would like to see all the folders in my system. So what I could do is just simply say, let me have a console.writeLine. Actually, I'll just copy this. I could just simply say enumerate directories. However, I would like to get dynamically where my exe file is at, because it could be anywhere in the operating system on the computer. So app domain dot current domain dot base directory. This will get you immediately the directory where the exe is located. And then I will, your exe, your program file, right? So if I hit Control F5, right now, this is where my exe located. It will say, here's my index demo, and here's my directory, right? So these are the two things I wanted actually to show you regarding how you can do some directory operations, like get directories, list them, list the files in a current directory, and so on and so forth. It's a very useful tool. I use it a lot when working with files in my projects. Now let's get back to indexing. Now, as I mentioned already, that I don't want to load the whole file into the memory. So what we usually do is we do something like a lookup tables. So if I actually run sheer MS Paint, imagine that you have a phone book of 1 GB size, and I would like to search for a name of a person. I don't need to load the 1 GB file in the memory to find the name of the person, right? All what you need to do is you could actually find this in a clever way. You could use, for example, B trees and B plus trees, and you can have like a super efficient way of dealing with this. But let's say that you didn't know about B plus trees and you wanted to solve this problem in a different way. What you could do is you do something which is called some indexing files. So what can be done is you could take your phone book and you can actually split it into multiple files, and you say, okay, all people that they have their names with letter A will be in that file, and all people with letter B will be in that file, and all people with letter C will be on another file, and so on and so forth. So with all the alphabet in, you can have people's name in these files, right, for every letter of the alphabet. And then when you find a name that is, for example, starting with a certain letter, you say, aha, okay, I know which file I'm going to search for. So right now you can actually have, instead of loading like 1 GB file in the memory, you'll just simply load, let's say, 2 MB or 3 MB file. Right now you are being a little bit more efficient, right? So let me show you what I'm talking about here. I just copied this index demo in here. And what the index does is you will see it right here. I need to get over this really fast because I need to cover serialization. Because serialization is actually what you're going to see in pair, near pair, I don't know if you're going to even see it, but hey. But it's used in production all the time, just to be clear. So as you can see here, I just simply said for letter A, you're going to have file 01. For letter F, you're going to have file 06. For letter P, you have file 15, right? And then if you look here at data, file 15, for example, let's say, I just went over the internet and generated names, 100 names, and I just simply split them into files. So right now, I have like, so number 4, it has letter D, so it has these names. Number 20, it has letter Z with these names, right? So you have all these guys in there, which is perfect. So right now the plan here is the following. I have a file, which is called an index, the index file, and I have several files, right? And whenever I actually search for a name, I will grab the first letter of a name. So if the name, for example, starts with letter C, okay, I will load this index into the memory. I will say, where is letter C, right? And it will tell me it's actually located in the file, let's say number 3. I will just simply go to file number 3, load it into the memory, find my stuff, which I need, and return back the result, right? So this is just the plan. It's actually quite easy. You could already guess from the simple read and write and key equal value. It is key equal value pair is going to be used, and simple read line once you actually reach the file is there. So let me show you how this is actually being implemented. So I'm just going to have file structures dot indexing. And I'm going to call this, I'm going to rename it right now to indexing. All right. Give me a second. Okay. So let's say you would like to find the name. So I'm going to have a public static void. Well, actually, I could have it like string find name. Okay. I'm just going to have string name. And this is where we're going to actually I would like to find the name. I would like to find people's last name, for example, or something like that. Or you can think of it like phone number or whatever, right? I'm just going to simply right now print in the full name. So I'm going to give the first name, and I cannot remember the guy's last name, so it will give me the guy's last name, whatever, right? Var found file equals to this, equals to an empty string. Because I need this outside so I can actually refer to it later. Because I don't want to keep the file open in the memory. For example, the index file, I don't want to keep it up in the memory. I would like to close it after I'm actually done finding where I would like to, which file I'm going to hunt for. So I'm going to have using var fs equal to new file stream. And right here, I'm just going to have indexing or index demo, I think it was, slash index.txt. File mode is opened. File mode dot open. Apparently, I'm actually missing the system.io. Yeah, all right. And then file access dot read. Here's another flavor which you guys haven't seen. And then I'm going to actually have, using var sr, and then I'm just going to do the stream reader bit. Now here comes the interesting part. Var result, or var, result, var index. You can actually, I'm going to call it var result for now. sr.read to end, right? Dot split new lines. So right now I'm just going to return an array or a list of indices, right? So I'm just doing this all in one go. Read till the end, it will return to me a string, right? So it will return to me this whole file in one big string with delimited with new lines. And I say split on new line, so it will return an array of, like, I don't know how many elements in there. It will return to me an array of 20 elements, I think. How many lines are there? 20 lines. Actually, 20 lines. Hang on. Notepads. Yeah, 20 lines. So it will return to me an array of 20 elements. And then I say just simply convert it to a list. So I have a list of files, right? A list of A equals to B, A equals to 1, B equals to 2, and so on and so forth. For each item in there, I can actually write down, if you would like to, I can print it out, but I will not write it. So let me just refer, no, I will not do that. Var first letter, name dot to lower, because I don't want to be hooked up to problems of like matching up the cases. So whatever, if you write high cap or low cap, I don't care. I'll just simply put it to lower or to upper. It's up to you. For me, the letters are already saved into lower right here. You see, A is lower, B, C, all of them are small caps. So that's why I need to search in the index file for them. So I'm saying, okay, what is going to be the first character of the name that I have, right? So it will say, yeah, I'm just going to grab the first character. I'm just going to make it smaller. I'm just going to say var line equals to result. And this is the stuff which you were doing with Dennis on pair 3 lectures, where, and then I say item goes to first letter equals item of 0, right? So I'm going to say, give me just the first letter, dot first or default. Okay. That line, so for every line, so it's actually for each line, please check the first letter in that line of a string. And the first letter is here, actually, right? If the letter was here, it's going to be like, I don't know what, like 0, 1, 2, let's say. So it's going to be in the second index or something like that. And since I know already the file format, I can just simply hard code it. By the way, file formats shouldn't change over the lifetime of the application. It has to be static. Remember that. If the file changes, it will break the previous application. So if you release a new application or a new version with new file format, you have to tell the users, hey, the new file format cannot be used in the older applications, can be used only in the newer applications. Right now, you know why when you upgrade applications, sometimes it happens that there is no backward compatibility, right? So that's an important point for you guys to know. All right, so we have the line. I could simply say var index. I'm not doing any checks, by the way. As you can see here, I'm just saying if it's not found or if it's found. I will leave this for you guys to enhance. Line.split. Right now I found which line, right? And I'm just going to say, okay, split that line on the equality sign, right? So yeah, I found letter C. It's at that line. It will return to you the complete line. I found letter C right now. Please split that line on that equal. So I found letter C. Split that line on that equal and give me this number, right? So I'm just going to say, okay, dot split, dot to list. And then I'm just going to say, give me the second element. And I'm simply saying dot trim. And trim, because I'm actually trimming Windows format for a new line or a new tab is /r. So I'm going to get a /r right here. You see this? This is a /r. I'm just simply trimming that. So that's why I'm attaching all trim. Removes all leading and trailing white space characters from a current string object. That's what I'm doing. All right, so, and I'm just going to say found file, not equal to the line, but equals to index demo /data / and then the index, which I found, plus .txt, right? So right now I'm just simply saying, okay, your file, that index, because I named the index according to the name of the file, and then I just simply say add it to it .txt, and that's it, right? Now I found the file. Now this is the file, right? It's right here, okay? And right now, once this is done, this indexing operation is all closed and disposed, done. Right now we do the reading bit. Now we actually find the record which we want within that file. So var fs equals to new file stream. And then I'm just simply say call it found file, because right now I'm going to give it the file which I found, the index file, or from the index file, sorry, file mode.open, and then file access.read. And then I'm just going to nest under it using var sr equals to new stream reader with fs, right? And right now I'm just going to say var result, to make it easier for us, equals to sr.read to end. You could actually read line by line. So you could actually have while sr.peak come on. sr.peak doesn't equal to -1. And then what you could do is say if item.split on spaces dot to list, because I'm actually like grabbing the line which I'm actually looking at. Yeah, actually I need to say sr dot read line first. I'm gonna assign it to item bar, and then I'm just gonna split that line dot to list 0 equals to the name I'm seeking for. Then I'll just simply say return item. That's it. We are done. Just return to me the item. Else return empty strings, because I have to return something, right? So I'm just gonna actually write here. Let me copy this here, and this is gonna be yellow. And I'm gonna take out the directory bits. I'm gonna actually take out all of this. I'm gonna write down indexing operations. Yeah, and right here I'm just gonna call this function which I created. Come on. Indexing, okay. What was the name of the thing? Yeah, indexing. Dot find name. And right now I'm just gonna write in. I need a name that I know that I can find right away. So, for example, this. So we know it has a Muller, I think, last name. So I'm just gonna write in this. And that's pretty much it. So let me hit Control F5. Oh, sorry, I need to, this returns a string, right? So I need to console.write line this, console.write line, and Control F5, I guess. And indeed, there you go. We just simply found it. Okay. So right now you know how to find strings through indexing. If you have an indexing infrastructure of some sort, right now you don't need to read the full file in the memory. You just simply read the part which you need, and this is it. You are done. Okay. So let's see here. So we have the CSV, cursor, indexing, key equal value pair. Yeah, Haris, now it's actually tons of fun, isn't it? Okay, so we have one more way of writing to a file, and then we call it a day. I'm not gonna actually I'm not gonna actually like show you all of it today. Maybe I will show you next time just one more part, and then we are good to go. I'm actually not gonna write that code in front of you, honestly, because I've written it only once, and I written it when I was a second-year student, and maybe I modified it a little bit, but I'm using it in my work ever since. Second year, maybe actually even earlier. I don't remember anymore. No, maybe even later. Okay, it doesn't matter. The next thing is serialization. So let me write this serialization. Serialization? File structure. All right, so I'm actually gonna copy this, to be honest, because I don't have, we don't have time to write this from scratch. The other ones, we needed it, but this one isn't. Let me try to import these guys and this guy. All right, so yeah, this is system.diagnostics. Okay, hopefully I don't have anything else. Perfect. Now, what a serialization does is, let me actually I don't need for deep cloning. Deep cloning is another story. What a serialization does, it takes an object, converts it into some sort of a graph, let's say, it's an object graph, and then writes it to a file, right? And you really don't need to know about the internal implementation of how serialization works, at least like for binaries or something like that. But all what you need to know is that you could write in objects or files, objects into a file. And even though it will not be human readable, but you will be able to transfer it. So this is one way to preserve objects, and you send it over a network. So for example, imagine that you actually, when you are actually logging into, let's say, I don't know, I wouldn't say email, but let's say your Facebook, whatever. I don't know the underlying implementation, but let's say for the sake of the argument, when you are actually logging to Facebook, you are not sending your username and password in clear text over the wire. You are actually it's being, of course, encrypted and everything, but it's being serialized. So this object of your login, we have a login object. This is just simply being converted into a certain format, and it's just sent over the internet. The other receiving end will do something which is called deserialization of the object. So it will restore the object as it was in your memory, right? So it will exactly, you're going to have exactly matching objects, nothing, exact copies with no loss of data, okay? So this is what the serialization is all about. Long time ago, long time ago, for legacy systems, we used XML. And and right now, this is called the SOAP formatters, right? Simple Object Access Protocol. Right now, because XMLs are actually quite big and clunky, right now people are actually using JSONs because of JSON, right? Everything is in JavaScript these days. And there's another one which is called the binary formatter, which I think is Microsoft stuff, I think. I don't know if it's cross-platforms, to be honest. I haven't tested it cross-platform. Actually, it is cross-platform. If you have in Mono, I think it's working in Mono perfectly fine. XML is not. I think XML requires that you're using Microsoft technologies. I think. If you would like to serialize in JSON, you use something which is called Newton JSON. And this is it. Now let me show you, this is just simply something that you use. So you just simply go ahead and I can let you just read that file on your own if you want to read this class. I'm gonna actually give you the source code in a minute of this whole project so you can experiment with it. I'm gonna upload it on DL system as well. So let me just copy this and right here I'm just gonna say serialization demo. And right here I'm just gonna have, let's say, magenta. And we are not gonna have this anymore. I'm just gonna add a reference to to File Structure Serialization. Oh, instead of hitting OK, I hit cancel. Dink, dink. And right here, I'm just going to have console dot, not console, serialize. Oh, I forgot the name of the class, honestly. Aha. Oh, there we go. So it's serializer. Ooh, that happened. Serializer dot, import that dot. And then here I have actually multiple ways of doing this. I could actually serialize a list or serialize an object. So I could just simply serialize a new student. Do you have a new student here? Perfect, we have one. So I'm just gonna copy this guy. So we serialize an object, which you can, by the way, an object means you can actually even serialize a collection. You can serialize a list. You can serialize a dictionary. Whatever has serializable on top of it. So if you have a student, you need to mark it with serializable. So the system actually says, aha, this actually can be serialized. Okay. The problem with serialization is that, again, you really need to read the whole thing into the memory. So if you have a serialized object of 1 gigabyte, there's no way that you can interpret a piece of it. You need to interpret the whole thing in order to work with it. Now let's see, what does it require as well? A file name. So I'm just going to call this a serialized student, right? And then right now I'm just going to have a console.writeLine serializer.deserialize object, and it is actually a generic, so it can actually recognize these things. And if you make a mistake, it will actually throw an exception. It cannot deserialize. It cannot deserialize that object of yours. Oh, hang on. I need just to make this, and this is a binary, so I'm just going to call it .bin for now. And this should be the file name. So I'm just going to say deserialize me the file name. It will return to me a student, and a student already implements or already has a toString override. So it's perfect. Now I'm just going to save this, and hopefully nothing explodes. And there you go. We have a serialization demo. I actually serialized it and deserialized it back. So if I actually go ahead here in, oh boy, now I have to find it. There you go, serialize student.bin. Actually, you cannot read this file. Well, this is funny. What? How come? Wait, hang on. Could it be that it doesn't read? Binary stuff? Oh, there we go. Actually, that notepads apparently cannot read binary. So there you go. This is your student object. So it is written in here. You cannot read this. You're just, the binary formatter can read this. It interprets it back, and that's it. So it's a binary formatter. All right. I'm going to actually stop right there and show you probably next time the last type of serialization, which is made by Google. And it is awesome. I love it very much. Very optimized, very lean and super fast. It's called protocol buffers. I use it actually in production. It's awesome. It's really good, and it's actually interoperable. Yeah, it means I write C# code, and I write I work with protocol buffers, and then somebody else writes code in Java, and they just simply import that file, the protocol buffer file, and converts it into Java code, and then Another ones, they convert it to another language. It's like it supports like I don't know how many languages already it supports. It supports many of them actually. Protocol, buffers, language. It has everything, I think. It has almost for every language. So basic C++, C#, Dart, Go, Java, Kotlin, and Python. I don't know. I think there is even more, but I don't know where. But in any case, we use it. It's another way to serialize file, and it is human readable. You can actually define how your file will be laid out. So how your serialization will be laid out, because everything is in binary. But you specify exactly how this binary is being formatted, the order of variables and stuff like that. And then it is highly optimized, so it knows exactly how much to read for specific things. And then you could just simply like, when you send it over the network, it's just going to be super small file that is just really being interpreted, and it's working super well, actually. I love it. Oh, dark code theme, perfect. All right, I'm gonna actually, yeah, so I'm gonna actually stop right here. And then next time, probably we're gonna look at the protocol buffers, how you can generate a protocol buffer file so you can see the process, because it might not be apparent from the beginning how to work with it. But yeah, I think this is pretty much it. Let me uncomment all these guys as well. Control KU. I don't know what will happen if all of them run at the same time, but hey, let's see if it will it crash? Okay, nothing crashed, perfect. So it works. All right. All right. Perfect, give me a second here. All right, let me stop recording.